Now that we know how to solve an equation by using the x-intercepts or roots, we can actually work backwards and figure out the equation for a graph if we can see where it hits on the x-axis. So we're sort of working backwards from our previous video. The first thing I'm going to do on this picture is I'm going to identify all of my roots or my x-intercepts. So I'm just figuring out where this graph hits the x-axis, and it hits at -3, -1, and +2 for this problem. What I'm actually going to do with my x-intercepts right here, I'm going to take them one at a time, and I'm going to think backwards from using the solution to make my equation. My first solution is at x equals -3 for this mystery equation. So if I'm thinking about y equals here for an actual equation, if I want the answer to be x equals -3, that would mean my parenthesis in this problem, my factor, would say x plus 3. You guys already know if you have a parenthesis and you have it 0 on the other side like this, just a bunch of parentheses being multiplied, you just equal them to 0 separately and solve. So if my answer is supposed to say x equals -3, well, x plus 3 has to be a factor. Similarly, if I have x equals -1, well, that means x plus 1 is going to be a factor in my actual equation. And finally, if I have x equals a +2, it's going to say x minus 2. You take your answer and you just think backwards and do the opposite to make each of your parentheses. If you solve these and equal them to 0, you will get the x-intercepts that you see. So this right here is actually my equation for this graph. If I wanted it to be in standard form, I could sit here and start foiling out these parentheses, but we're not going to do that in this video. One thing I'm going to toss on with this equation right here, I can't say for sure what number goes in front for a coefficient. Like, is this a 2 up front right here? Is it a 7? Is it something else? I have no idea. But I do know this graph starts low and goes high. It's going low to high in this picture. So whatever number goes in the front of this equation, it has to be something positive. So I'm just going to put a little plus sign in the front of this equation to remind me that it is a positive number. So I can learn a lot about the equation of this graph just by knowing the x-intercepts. Let's do another one just like that. Looking at where this graph hits, it appears that I have -5 as a solution. I have -2. I have 0. And I have a +3. All I'm going to do is take those answers one at a time and put them in a little parenthesis for a factor. If it's x equals -5, I'm going to have x plus 5. X equals -2, cool, I'm going to have x plus 2. X equals 0, you could write x plus 0, you could write x minus 0, or you could just write x. Any of those would be acceptable for this answer right here. And lastly, if I have x equals 3, I'm going to write down x minus 3. Those are going to be my factors to this equation. I do see that this graph is pointing down on both sides right here. So this must be some sort of a negative number in the front of my equation. So I can very quickly make a factored equation if I know the x-intercepts. Okay, so let's write that down as a quick note. Use the x-intercepts to create each parenthesis. And that's basically our setup right here. Now let's do one more problem. On this last one, I see that this graph hits at x equals +2. That means my equation for this one needs to have an x minus 2. But you'll notice this is the only time my graph hits the x-axis. It doesn't hit any other times. Clearly, this isn't just the equation y equals x minus 2. This graph is a polynomial. It's got lots of bumps, and that's a linear equation right here. So this method doesn't work with graphs that have imaginary solutions. The other answers to this equation right here are actually imaginary numbers. So we don't see any additional x-intercepts, and I can't keep making my equation on this problem. We need to use fancier math to get the rest of our equation. But if your roots hit on the x-axis everywhere, this is a really quick way to write a good equation for a polynomial.